Alright, so today we are going to be talking about the angles of triangles a little bit further. So, the goal for today is that you can apply the triangle angle sum theorem and apply the exterior angle theorem. These are not as bad as their names sound. So, first thing, an auxiliary line is a line to it's an extra line that you add in to help prove something. This is often used with like exterior angle theorem is the most popular one. Exterior angle is an angle that lies outside of the polygon. So we'll get into more of that today. It's easier with pictures, but essentially what that would be is if we had this triangle and then we extended that line, this angle here would be our exterior angle. Remote interior angles, those are interior angles that don't share a vertex with the exterior angle. A flow proof uses a diagram to show statements leading to a conclusion. It's a different type of proof. We typically do two-column proofs, and honestly, two-column proofs are way better than flow proofs. Flow proofs are just kind of messy typically. Very seldom do they actually serve a rock solid purpose. So we'll continue to do more two-column proofs than flow proofs, but we will look at a few flow proofs today and in the following lessons. And a corollary is a theorem that follows another theorem. This is a tricky definition. It'll make more sense as we go through it, but essentially what that means is like if the first theorem is true, then the second one must be true as well. So like if the fish I can't even think of a good one right now. Moving on. So triangle angle sum theorem. What this pretty much says is if you add all the interior angles of this triangle, they're going to add up to equal 180 degrees. So if you add angle A, angle B, and angle C, they're going to add up to equal 180 degrees. And that is true 1000% of the time. Every single time you have a triangle, it's going to add up to 180 degrees. So triangle angle sum theorem pretty much has this long drawn out proof showing why it's true. Essentially what this is saying is, okay, angle 4, 2, and 5 add up to equal 180 degrees, and then they drew in this auxiliary line, this line AD, and then if we just focused on, let's get red, if we focused on that line, this line, and then this transversal, what this, oh man, that was horrible. What that would show us, I mean, none of them are that great, but so what this would show us is that angle 5 and angle 3 are congruent. And then if we did the same thing going the other way, we could show, so we still have those two parallel lines, and then we have this transversal, AB. What this shows is that 4 and 1 are the same. And so basically what they're trying to show is that if 1 and 4 are the same, 3 and 5 are the same, and 4, 2, and 5 add up to equal 180, then 1, 2, and 3 must also add up to equal 180. It's really a long, drawn-out, confusing way of saying that. But big picture in the proof, you can pretty much skip steps 2, pretty much 2 through 7, and kind of get the same general picture. This isn't like a proof that you guys would write, but it's just a proof showing that a triangle does in fact add up to 180 degrees. Okay, so we're using the triangle angle sum theorem to solve this problem. So the diagram shows the path of the softball in a drill developed by 4 players. Find the measure of each numbered angle. Okay. Right away, I know angles 1 and angle 2 are going to be the same. So for me to find one of these, I need to use whatever triangle has 2 other angles. So right away, I see this triangle on the left here has 2 other angles. So if I add up 43 plus 74, we get 117. And then, so from there, so our 2 angles here add up to 117. So we need to find out what angle 1 is. So if we subtract 117 from 180, that's going to tell us angle 1, because we know 43 plus 74 plus angle 1 needs to add up to equal 180. I didn't do a really good job of showing that, so let's erase. All right. So if we do 43 plus 74 plus angle 1, that's going to equal 180. So if we solve this, we can subtract 43 and subtract 74 from both sides, which is going to be the same as subtracting 117. And we find out that angle 1 is going to equal 63 degrees. And if angle 1 equals 63 degrees, then angle 2 also equals 63 degrees. And the reason for that is that they are vertical angles. They're straight across when they intersect. So now we're going to do the same thing on this other side. We're going to say 79 plus 63 plus angle 3 is going to equal 180. And then if we subtract 79 and 63 minus, what would that be? That would be 80. 142 minus 142, we end up with angle 3 equals 38 degrees. So that would solve for every... that got out of hand. So that would solve for every numbered angle. You're going to see a lot of problems that want you to solve for every numbered angle. This is just a concept that we're going to get very used to. So find the measure of angle 3. So in triangle ACB, we can see that we have 2 unknown angles. But once again, I can see that angle 1 and angle 2 are the same. And in triangle DCE, we do have 2 angles. So I'm going to say 38 plus 67 plus angle 1 is going to equal 180, because that's all 3 angles in this. And then if we do subtract 38 and subtract 67, which would really be subtracting 105, we end up with angle 1 equals 75 degrees. So if angle 1 equals 75, then angle 2 also equals 75. So once again, because they are vertical angles, so if we add up 75 plus 48, we're going to get 100. I'm trying to do this in my head and it's just not going well today, folks. So carry the 1, would be 2, 123. So 123 degrees for these 2 angles, which means our final angle is going to be 57. So our final answer would be C. Alright, so exterior angle theorem, what that says is a measure of an exterior angle of a triangle is equal to the sum of the measures of the 2 remote interior angles. So in this example, what that would say is angle 1 equals angle A plus angle B. Alright, so essentially why this is because if we take, so angle A, B, and C are going to add up to equal 180. And so the other thing that's going to add up to equal 180 is angle 1 plus angle C, because they combine to make a straight line. So if we set those equal to each other, essentially AB is always going to equal angle 1, which is what this theorem is stating. This is a flow-proof for exterior angle theorem. We can walk through it, but I don't think it serves much of a purpose. So this starts off, says, triangle ABC is given. So triangle ABC is given. All their angles add up to equal 180 degrees. Delightful. They say 1 and 2 form a linear pair, which is true. Then they say 2 and 1 are supplementary, which seems a little bit extensive since they are a linear pair. So angle 1 and 2 also equal 180 degrees. So we have all three interior angles of this triangle, and angle 2 and angle 1 all add up to equal 180 degrees. So when we substitute and set those equal to each other, everything gets canceled except for measure of angle A plus angle B equals the measure of angle 1. We'll talk more about this in class on Tuesday, but that's the gist of it. So you're going to see a lot of algebraic problems with this. So they want us to find the measure of angle FLW in the fenced flower garden. So FLW is this angle right here, and it has the value of 2x minus 48. Let's see, what should we do next? Okay, and we know FLW is going to equal angle O plus angle W. So based on that exterior angle theorem, we could say x plus 32 is going to equal 2x minus 48. So we could go ahead and solve this equation to find out what x equals, and then we could use that to find out the angle of FLW. So my first step, I want to subtract x from both sides, which leaves us with x minus 48 equals 32. And if we add 48 to both sides, we are left with x equals 80. So we have x equals 80, but we do not know what angle FLW is yet. And they don't want what x equals. They want angle FLW. So what we have to do is we have to take this x equals 80, and we have to plug it back into that initial 2x minus 48. So if we say 2, and then instead of x, we're going to say 80 because we're substituting in minus 48 equals angle FLW. We are left with 160 minus 48 equals angle FLW. And 160 minus 48 would be 112 degrees equals angle FLW. So 112 degrees would be our final answer. Yay! Okay, we're getting down to the end of this. So the piece of quilt fabric is in the shape of a right triangle. Find the measure of angle ACD. Okay, so they want us to find this 3x plus 10, what the actual measure of that angle is. And of course, we know this is 90 degrees. So we could say 90 plus x is going to equal 3x plus 10. So we could go ahead and start solving that, which would be 80 equals 2x, so x would equal 40. But then we're not done. We have to actually plug that x equals 40 back in over here, which would leave us with 3 times 40 plus 10, which would be 120 plus 10. So we would end up with 130. Delightful, delightful, delightful. All right, so triangle angle sum corollaries. So this is just a way to abbreviate these if you were to write a proof. I'll let you copy those in your notes. We're not actually going to go over them. They're just shorthand ways to write things. Find the measure of each numbered angle. So this one is a hot mess, but that is okay. So what we're going to do is we're going to start. I'm going to highlight every single angle we need. So we need 5, we need 3, we need 2, we need 4, we need 1. Okay. So right away, what I'm looking at here, I see one triangle that's very attainable that we can find right away, and it's this yellow one over here. So I see that we have, and I'm going to write kind of small to try to keep things organized. So I know we have 90 plus 41, and so we're going to, I should rephrase that. So we have angle 5 plus 90 plus 41 is going to equal 180. So if I want to go ahead and solve that, what I'm going to end up with is that angle 5 is going to equal 49 degrees. So right away, we've solved angle 5 equals 49 degrees. All right. So now we have to figure out which other ones we can solve off the bat. Angle 3, there's a lot of unknowns there. Okay, here's one. So this one's a little far-fetched, but I know it's doable. So angle 2 is a vertical angle to this angle right here. Let's not do a 0, let's do a question mark. And I can see that 48 plus 56 plus question mark is going to equal 180 degrees, because we're dealing with this lovely little blue triangle here, and they're only missing this bottom angle. So if we were to go ahead and solve that, we would end up with 114. So I think it would be 114, 90, 104, so 76. So we would end up with a 76 degree angle there. So this question mark would be 76 degrees, which would also mean angle 2 is 76 degrees. All right. So we're getting somewhere. Angle 2, 76 degrees. Okay, I think we can solve angle 4 now. It's going to take a little bit of doing. Oh, you know what? I lied. Let's solve angle 1. Angle 2 and angle 1 form a straight line. So they're a linear pair, and angle 2 is 76 degrees, which means angle 1 would be 104 degrees. So angle 1's 104 degrees, so we have 2 angles left to solve. Let's go ahead and solve, which means this one would be 104 degrees also. Okay, let's actually solve for angle 3 then. So angle 3, so I see this triangle, let me highlight it in blue, just like the last one. So this lovely triangle right here, we have 34 degrees plus 104 degrees. 34 plus 104 plus angle 3 is going to equal 180. So 34 plus 104 is 138, which means the third angle is going to be 42 degrees. So angle 3 is going to be 42 degrees. And I know I'm doing a lot of this in my head, but the long story of it is, whenever I see, when we have 2 angles, what I'm doing in my head is I'm saying, okay, 34 plus 104 equals 138. And now that I have the 138, I know I want that to be 180 degrees. So I'm asking myself, how many more do I need to get to 180? So I'm saying 138 plus what is going to equal 180? Is essentially my methodology. So angle 3 is 42. Now we can figure out 42. So angle 3 plus 90 degrees is plus 4 is going to equal 180. So we have 42 for angle 3 plus 90 plus angle 4 is going to equal 180. So 42 plus 90 is going to equal 132. Plus 58 is, no, plus 48. Yeah, plus 48 is going to equal 180. So that means angle 4 is 48 degrees. Okay, so we'll talk more about this in